This is Unit 6, Day 5. Today we're talking about complex fractions. Okay, so basically a complex fraction, something that's complex, means it's hard or there's a lot to it. And a complex fraction is when you have a fraction that its numerators are fractions and its denominators are fractions. So you have a fraction plus a fraction divided by, which is a fraction, another fraction. So you're like fraction crazy. All right, so if you look at all three denominators, so 9, 18, and 3, you have to find the least common denominator, also known as the LCD, amongst those three. Now be careful. You can't say 3, okay, because 18 can't go into 3, okay? 9 can't go into 3. So the least common denominator that they can all share is going to be 18. 3 can go into 18, 18 can go into 18, and 9 can go into 18. Okay, I want to point out to you that if I choose 18, 18 over 1 means the exact same thing as 18. But I like the fraction form of 18 over 1 versus 18. All right, now what you're going to do is you're going to rewrite the original question. Okay, so here's the original question. I'm writing it in black. But now, if you read this, it says multiply the numerator and the denominator by your answer from part A. So they're basically telling you you have to multiply each piece by 18. Now remember, guys, instead of me just writing 18s, I'm going to write 18 over 1 just so that it's more pleasant to the eye that they're all fractions. Okay? So each fraction, I'm going to multiply by the LCD, which is 18. Now, it's a little organized to keep them boxed in. Each blue box that I write right here, I'm going to reduce these two fractions. And remember, you can cancel any numerator with any denominator. So this 18 and this 9, I could divide them both by 9, and I'm left with 1 and 2. Okay? This 18 and this 18, they divide out both by 18, and they leave behind 1s. And in my last blue box, I have 18 and 3, divide them both by 3, and I get 18 and 6. If you do this right, all and every denominator turns to a 1. So now my first blue box is 2 times 1 all over 1 times 1, and that's a big 2. Okay, carry down the plus right here from the middle. Same thing over here. Now I have 1 times 1 all over 1 times 1, which is another 1. So my numerator is just a 3. 2 plus 1 is 3. If you use the LCD method correctly, those fractions get wiped out. Okay? The bottom, I have 1 times a 6 all over a 1 times a 1, which is 6. 3 out of 6 reduces to a half. Okay? So the answer to this question is a half. All right? We're going to do it again. So again, this is called the LCD method. So now if you look at all of your denominators again, we have 3x and 3. Okay, so this is kind of good review for adding and subtracting fractions. So the LCD method, what do they all have in common? They all could use a 3 and they all could use an x. So 3x is my LCD. So I'm going to write down the original fractions in black. And now I'm going to have to multiply each of these minor fractions. These are called minor fractions. Each of those minor fractions are going to be getting multiplied by the LCD. So again, they're all going to get times by a 3x. Now guys, remember, 3x over 1 is the same thing as 3x. So every single one of these are getting times by 3x over 1. So now I'm going to make 4 blue boxes. Why 4 this time? There's 4 fractions instead of 3 fractions. And now you're going to reduce each fraction. So any top can be reduced with any bottom. So the only thing that reduces here are those 3's. The 3's are gone. They leave behind 1's. Be very careful in this first box. You have 1 times an x times a 2 all over 1 times 1. So you're really just left with a 2x in that first blue box. So I have a 2x. Okay? Going to the second blue box, you have x and x. They both cancel each other out, leaving behind 1s. So now I have 2 times 3 times 1, which is 6, all over 1 times 1. So I'm left with just a 6. Okay, the bottom. 3's cancel again, leave behind 1s. Again, don't forget, I have 1 times x times 5. That's a 5x on the bottom. And then the last blue box here, my x's are gone, they leave behind 1s. I have 5 times 3, which is 15. Okay? Now, one thing you have to realize, you can't cross off x for x or divide 6 and 15 both by 3. This is a marriage, this is a marriage. So you must factor. So I have to take the GCF of the numerator and the GCF of the denominator. So if I do a greatest common factor to the numerator, I'm left with x plus 3. And again, that's review back to factoring back in Unit 3. The denominator I can factor out a 5, and I'm left with x plus 3. So now that these marriages match, they leave behind 1s, and the answer to this is 2/5. Okay? B, C, and D, we call them nice because they all have monomial denominators. Okay, so again, you're looking at 8, 4x, 2x, and 4. So my LCD, okay, you can't tell me it's 2 because 8 can't go down to 2 and 4 can't go down to 2. So they all can go into an 8, but if there's at least one x there, you need an 8x. So 8x is my LCD. So again, copy every single fraction that's already there, that was given to you. And hopefully the color coding is really helping you. So basically, this is the original problem that was given to you. And I'm going to multiply them all by 8x, which is my LCD. Put it over 1, so it's a little bit more pleasant to the eye. And again, we have 4 blue boxes. And I'm going to reduce any numerator with any denominator. Be careful. Okay? So this first blue box, the 8's are gone. But now I have an x times a 1. So 1 times x times 3 all over 1 is going to be a 3x. Okay? In the second blue box, the x's cancel, leave behind 1s. The 4 and 8, you could divide them both by 4. And I'm really left with a 1 times a 2 times a 1. So I'm just left with a big 2. Okay? On the bottom, x's cancel, leave behind 1s. 8 and 2 reduce, leave behind a 4 up in the numerator. So I have 4 times 1 times 7. And 4 times 1 times 7. Is going to be a 28. Okay? Alright. Last box here. I'm going to have a 4 and an 8 reduced, leaving behind a 1 and a 2. And I'm left with a 6, because it's 3 times this 2, and x times my x is going to be x squared. Okay? Alright, now the last thing, again, x and x can't cancel, 2 and 28 or 2 and 6 can't cancel because they're married. So maybe I could try and take out a GCF on the denominator. Okay, so you're going to say, well, what can I divide out of a 6 and a 28? Well, 28 would be what? 2? Yep, and you're going to take out a 2. Okay, when you divide out a 2, you're going to be left with 14 plus 3x squared. Okay, 14 plus 3x squared. And the numerator is 3x plus 2. Okay? Alright, so again, this is still a marriage, that's a marriage. So the only thing you want to make sure is that nothing cancels with that single, but it can't. So that's going to be your answer. Okay? Alright. Part C. The only thing I want to do with you guys is I want to teach you another method. Okay? It's called the horizontal rewrite. And that's just me naming it because you're going to rewrite it horizontally. Okay, so what does that mean? That means take this original numerator, So I have 1/2 minus 2 over x squared. That's my numerator. And instead of having a fraction bar, I have a division sign. And then I'm going to copy the denominator, which is 3 over 2x minus 3 over x squared. Okay, so there's my horizontal rewrite. Now, your goal is to make this go to one fraction and to make this go to one fraction. So for this first little set of parentheses, ignore all of this, okay? So just look that you have 1/2 minus 2 over x squared. So how do you subtract fractions? You need to get common denominators. Okay? So I'm going to say to myself, what can 2 and 2x squared go into? My common denominator is going to be a 2x squared. Okay? One thing to pay attention to, this is subtraction. So I usually go plus, and I know that's a -2. Alright? So now you're going to say, how does a 2 change to a 2x squared using multiplication? Well, I multiplied it by an x squared. Because 2 times x squared would be 2x squared. So whatever I do to the denominator, I have to do to the numerator. So 1 times x squared is just an x squared. Okay, carry the plus in the middle. And then how do I change an x squared to a 2x squared using multiplication? Well, I times it by a 2. Because 2 times x squared is 2x squared. So I multiply that -2 times a 2, and I end up with -4. So I keep and carry the 2x squared. And x squared plus a -4 cannot combine, so I just have x squared minus 4. Okay, there's my first fraction. I'm going to do the exact same thing for this fraction. So I have to get common denominators. Again, don't forget it's subtraction, so I just kind of go plus negative. Alright, so 2x and x squared is going to have a common denominator also of 2x squared. Okay? So now, how does a 2x change to a 2x squared? I multiply by an x. What I do to the denominator, I must do to the numerator, and it results in a 3x. Again, guys, because 2x times x is 2x squared, so therefore I'm going to get a 3x up top. Alright, over here, second fraction, how does an x squared change to a 2x squared? I multiply by 2. So I'm going to multiply the numerator by 2, and I end up with -6. So this is going to be 3x minus 6 all over, keep and carry that 2x squared. Okay, again, you can't combine a 3x minus 6, so it just gets carried down. Now, if you look, I have a fraction divided by a fraction. In high school, we say we multiply by the reciprocal whenever you divide fractions. Back in middle school, they called it keep, change, flip. Okay? So we're going to keep that first fraction. That first fraction, I'm going to come up here, guys. I'm running out of space. Is going to be x squared minus 4 all over 2x squared. You're going to change it to multiplication, or that's the multiply by. And its reciprocal, or the flip, means you need to flip that fraction, reciprocate it. Okay? Now, we have to factor. This is a DPS. This is a GCF. So this is going to factor to x plus 2 times x minus 2. 2x squared is single. That stays. The other 2x squared is also a monomial. That stays. And this is another GCF, and I get x minus 2. Remember, you can cancel any numerator with any denominator. Look at, these are exact matches. So they're going to leave behind 1s. This is a matching marriage. They leave behind 1s. Now, it doesn't look like there's much left to reduce. So in the numerator, I have a big 1 over here, a 1 here, and an x plus 2. So I'm left with x plus 2. Okay? On the bottom, I have a 1 times a 3 times a 1. You're left with 3. There's my answer. Okay? This is called the horizontal rewrite method. Okay? If you use the LCD method, your LCD would be a 2x squared, put it over 1. So now you would just multiply each piece by 2x squared.